Chapter 3, Lesson 6, Arithmetic Sequences. Arithmetic sequences are sequences where each term is found by adding or subtracting a constant to the previous term. So basically, we're looking for addition and subtraction patterns. Determine whether each sequence is arithmetic sequence, write yes or no, and explain. So on each of these, I'm just going to check if there's a constant number that is being added to each of them. So I asked myself, how do I go from 21 to 13? And the answer is I'm minus 8. Then I asked myself, 13 to 5, is that also minus 8? And 5 to 3, is that also minus 8? And the answer is yes. Number 4, to go from 1 to 4 is add 3. And from 4 to 5 is add 5. Has to be the same number, so this one is no. On this one, 5 to 12 is plus 7. 12 to 29 is plus 17, so this is a no. On this one, 9 to 16 is plus 7. 16 to 23 is plus 7. And 23 to 30 is plus 7. Yes. After we've determined if it's an arithmetic sequence, our next step would be to find the next three terms. So I already know this is an arithmetic sequence, so I need to find the constant. So to go from 82 to 76 is subtracting 6. 76 to 70 is subtracting 6. So I'm going to continue the pattern. So 64 minus 6 is 58. 58 minus 6 is 52. And 52 minus 6 is 46. Sometimes if they're a little bit difficult to find out what the pattern is, you can start from the back and work backwards. So if I don't know what I would add to negative 49 to get to negative 35, I can actually work backwards and use subtraction to figure out what it is. So in this case, I would take negative 7 and I would minus negative 21, which gives me positive 14. And if I go ahead and check my work and I take negative 49 plus 14, that gives me negative 35. So I'm going to plus 14 here to get 7, plus 14 again to get 21, and plus 14 again to get 35. Same thing here. If I didn't know that going from 12 to 10 was subtract 2, I could work backwards. 6 to 8 is minus 2. Okay, so then to fill in the next three blanks, I would subtract 2 from 6, which is 4, subtract 2, which is 2, and subtract 2, which is 0. Now, in the next part of your homework, you're going to have to actually write the formula for the arithmetic sequence. And so to do that, we have this formula here. Go ahead and pause and put that in your notes. A1 here they're referring to is the first term of the sequence. So you replace that A1 with whatever the first term is. So in this case here, I would put 9. Then you're always going to have plus, parenthesis, n minus 1. And n is going to be the term you are solving for. So if they tell you to find the 8th term, you would put 8 in for n. And then you have n minus 1 in parentheses, and then behind you have times d. And d is your constant difference. So that number that we were finding that was giving us the pattern. So in this example here, it says write an equation for the nth term of each arithmetic sequence, then graph the first 5 terms. So I'm going to start with 9 because that's my first term, plus, and in this example, they just say the nth term. So they're not giving me what n is, and so I'll just leave that as n minus 1. And then I have to solve for the common difference. So going from 9 to 13 and 13 from 17 is timesing by a positive 4. Then they give me 4 terms here. And so if I add 4 again, the 5th term would be 25. And so when I go to graph it, the first term is 9. Second term is 13. third term is 17, fourth term is 21, and the fifth term is 25. On number 14, to start my formula, I'm going to start with -5 plus parenthesis n minus 1. And then I have to find my common difference. So going from -5 to 2, -2 to 1, and 1 to 4 is +3. Kem deposited $115 into a new savings account. Each week thereafter, he deposits another $35. Write a function to represent the balance of Kem's savings account for any number of weeks after his initial deposit if he makes no withdrawals. So I'm going to start with my initial term, which is 115, plus n minus 1, and then my common difference is each week is 35. What is the balance of Kem's savings account 30 weeks after his initial deposit? So now they're giving me the nth term, which is 30. So I'm going to put 115 plus parenthesis 30 minus 1 times 35. Which gives me $1,130. Tamika is stacking boxes for store display. Each row of boxes has 2 fewer boxes than the row below. The first row has 23 boxes. Write a function to represent the sequence. So we start with our initial box stack, which is 23, plus parenthesis n minus 1. And this time it says it's 2 fewer boxes. So my constant difference is going to be a -2. How many boxes will there be in the 10th row? So I'm going to put in 23 plus 10 minus 1 times -2. And the answer is 5 boxes.